Hello and welcome to another section on statistics. Today we're going to look about how we organize, display, and interpret categorical data. So let's first talk about a couple of different data types. One is qualitative data. So we have qualitative and quantitative. Qualitative data consists of values that can be placed into what we call non-numerical categories. Let me give you an example. So what would be a non-numerical category? If I am surveying people on the brand name of shoes, the brand of shoes they are wearing, then I would be collecting a name, right? The brand name of the shoe. That's non-numerical. So that's what we would consider qualitative data. Quantitative data represents counts or measurements, numerical categories. When dealing with quantitative data, though, it is often useful to group, or what we call bin, the data into categories that cover a range of possible values. All right, let's do some examples here just so you can kind of see when we have qualitative and when we have quantitative and qualitative. Oh, I didn't even realize, look at that. I was pulling that out of my head, the brand name of shoes, but it turned out that was my sample, which is probably why it was in my head. So I just gave that one away. Brand names of shoes. So we just said, well, then that would be qualitative because it's non-numerical. Heights of students. Well, heights are measurements, right? We can write down everybody's height. That's a number. That's a measurement. So that one would be quantitative. And then an audience ratings of a film on a scale of 1 to 5, where 5 would mean excellent, maybe 1 means horrible, didn't like it, whatever it was. But each number is assigned its own category, right? Its own meaning there. Now, this one you have to be careful with, because it's a scale. Yes, you're rating it with a number, but the numbers, let me explain this. Although the film rating categories involve numbers, the numbers represent subjective opinions about the film, right? Because each number, for example, we just said 5 means excellent. It's not really counts or measurements. So these data would actually be, believe it or not, qualitative, despite that it's being stated as numbers. But again, these are subjective opinions where each number is assigned a particular meaning. All right, so I wanted to do that one purposefully to kind of show you where sometimes we might have to pause a little bit to ask ourselves, what exactly do these numbers represent? All right, I'm going to do an example here where we're working with percents. 31% of American adults surveyed stated that giving up their phone for a day would be more difficult than giving up their significant other. In 2012, the United States population over the age of 18 was about a little over 240 million. I'm not going to say the whole number. According to recent research from Pew Foundation, 91% of all American adults have cell phones of some type. Use the statistics given to determine the approximate number of American adults who would find giving up their phone more difficult than giving up their partner. So in this particular problem, this is actually going to be a couple of steps, because first of all, we need to figure out approximately how many people of the population given has a cell phone. So we're going to take the number and we're going to, because this is the population, and notice it says that approximately 91% have a cell phone of adults. So we're going to take that and multiply that by 91%, which would be 0.91. Multiply those two numbers, and we get 218,591,100. Okay, so that's approximately adults who have a cell phone. Number 2, now we're asked how many of those surveyed, right? So we looked at how many were surveyed. It was 31%. Now we're going to make some inferences. So this goes back to the last section we talked about From the survey, we're going to make some inferences about the population. Now we want to approximate the number then of American adults who would find giving up their phone more difficult than their partner. Well, in the statistics, it says 31%. You can see I'm underlining it up here. 31% of these adults who have a cell phone. So we're going to take the number that we found in step 1, and now we're going to multiply that by 31%, 0.31. And that gives us 67,763,241. So that is the number that we want to answer the question. Let's try another number. So this is where we're taking a sample, right, and these problems, and we are assigning it to the population, making inferences from the descriptive statistics. All right, number 2, 50 million of 94 million households watched the last episode of a popular television show. What percentage of households were not, there's your key word there, not watching the show? Well, first, again, 2 steps with this one too. First, we have to figure out, okay, well then, how many did not watch the last episode? It says that 50 million of 94 million watched it. So how many did not watch it? Well, it would be 94 minus 50, which is 44. So 44 million, I'll just put did not watch. Well, then number 2, because it's asking us what percent were not watching the show. Well, that would be the 44 million out of the 94 million. 44 out of, right? So that would be over 94. Let's round this number to 3 places. And so I see 0.468. And if we turn that to a percent, because it did ask us for a percent, that would be 46.8% that did not watch the show. All right, next, we're going to talk about frequency charts and tables. Now, what is a frequency distribution? One way to organize your data, because when you collect data, it's what we call raw data, right? It's not in any particular order. It's just a bunch of data. One way we can organize that data is through a frequency distribution. And this is basically you take the data listed, right? And then you create the frequencies with it. So you have your observed values and the frequency of occurrence for each value. Let me kind of show exactly what that means. Like I said, sometimes we understand it better when we see an example. Suppose a teacher, I'll stay right there. Suppose a teacher gives a quiz, and out of 10 possible points, the class of 25 made the following scores. Prepare a frequency distribution for this situation. We look first at the possible scores. It can be anywhere from 0 to 10. So the first thing I'm going to do is I'm going to create this little chart. On the left is the score. Whatever the data is, this is what you label as a left. In this case, it's scores, so we're going to put scores. On the right is always going to be frequency. Now what we do is we look through the chart and we write down all of the possible values. Well, you could get anywhere from a 0 to a 10. Okay, now I'm going to have to add a little bit more of a line there. Oops. Let me just undo that real quick. There we go. And let me just draw that down. There we go. All right. Then what we do, and I'm telling you this is not hard, I promise. You just look at the left and your frequency means how many. It's the count. How many zeros are there in this data? How many ones are there? So looking here, I see 2 zeros. So that would be my frequency. How many ones? There's 1. How many 2s? 1. Oops, that did not look good. Let me go back there. Okay, there we go. How many 3s? There's 0 3s. We put that down. How many 4s? I see 2 of those, and so forth. So you can see how much we do this. So, and then you count how many 5s. We have 4 of those. How many 6s? There are 3. 7s, there's 2 7s. 8s. 8 has the most. There's 5 8s. And then we have 3 9s and then 2 10s. Now, if you want to make sure you got all the numbers, add up all of these. Like, take all these numbers and add them together. And if we add every single one of those numbers, we do get 25. And there were 25. I'm looking up here, class of 25. So we're good there. We know that they made, so I got all of the numbers in there. So always add that because sometimes it's easy for our eyes to miss a number. Now, there's something called relative frequency. The relative frequency of any category is the fraction or percent of the data values that fall into that category. Let me just kind of show you the formula. So relative frequency, well, that did not come out like a nice cue. What it is, it's the frequency in that category divided by the total frequency. For examples, let's just do a quick example here. Let's say you wanted to find the relative frequency of a score of 8. Okay, let me just kind of show you over there, right? So right here, the score of 8. Take the frequency in that category. So how many 8s did we have? We had 5. What's the total frequency? Well, that's how many we had altogether, which is 25. Now I could reduce that into 1/5, or, so notice it says in here, you can write it as a fraction or as a percent. So if you take 1 divided by 5, you're going to get 0.2. So as a percent, that would be 20%. That means that 20% of the data consisted of a score of 8. That is our relative frequency. Let me go down to cumulative frequency. It's the number of data values in that category, but all the preceding categories. That would be your cumulative frequency. And I'm not going to do an example here because we're actually going to do an example in a couple minutes in the video. Probably, actually, I think it's the next one, example 2. So we're going to do this example first. In a class of 100 students, 41 students received a grade of a B. What was the relative frequency of the B? And explain your reasoning. So again, relative frequency, that would be the frequency in that category. So 41 students had a B out of 100 students. Now, you can change that to a decimal, or you can write that as a percent. All 3 of these are correct. It just depends on how we want to display our answer. But now I'm going to go to number 2 because this is going to be a good one. Because with this particular one, we are looking at frequencies, relative frequency, and cumulative frequency. So a professor records the final grades in one of her courses. Construct a frequency for the grades. All right, there are every grade. So we have A, B, C, D, and F. Now, the frequency. So remember, frequency, we're just going to count. So I'm going to count how many we have of each one. I see 3 A's, 8 B's, 7 C's, 4 D's, and 2 F's. Okay, that's that part. Relative frequency. So remember, relative frequency, and all together, how many do we have? Let's make sure we add this up because that tells us our total frequency. And there are 24. All right, now relative frequency we talked about. You take the frequency in that category, so this is the frequency for an A, and divided by the total frequency. Oops, that should be a 4. So 3 divided by 24, that would be 0.125 or 12.5%. Then you do this for each one. So this would be 8 out of 24 or point, and this one's just going to keep repeating. So 0.333, and it just keeps going. So we'll say 33.3%, so like a third. And then we have 7 over 24, and that would be 0.292. 4 out of 24, and that is 0.167. Just writing them down in all the ways. And then finally 2 out of 24. And remember, this is just telling me, for example, if I look at the percent, that this is telling me that 8.3% of the grades were an F. 12.5% of the grades were an A. All right, now let's switch to cumulative frequency. Cumulative frequency now, so now I'm going to kind of show you an example what that description meant previously, like about a couple minutes ago. Cumulative frequency. So you start with the frequency. The first frequency, there's 3 A's. That's all I have. Cumulative means we're going to keep adding from the previous category. So in the next one, we have 8 B's, but now we add the 3 from the previous. So that's 11. Now I start again here. So this one I have 7 C's, but now I have to add the 8 and the 3, and that gives me 18. And then we keep doing that. So 4, and then plus the 7, plus the 8, plus the 3 gives me 22. And then last but not least, 2 plus the 4, plus the 7, plus the 8, plus the 3, and that gives me 24. These are what we call the cumulative frequency. Okay, so I wanted to just kind of show through that one how we do relative and cumulative. Last part, we have something called bar graphs and pie charts. These are all different ways that we can organize our data, but also display our data. And we have more to come in other videos on other parts of descriptive statistics. But a bar graph, it's a visual way to look at your data. And there's a lot of different ways. We have histograms, bar graphs, circle, pie charts, circle graphs, that's another way of calling it. Line charts, there's a lot. Scatter plots, I mean, I could keep going here, but a bar graph displays a bar for each category. So let me just show you an example using the grades that we just did. So we'll kind of continue with that. With a bar graph, so you're going to pick your frequency. So I'm going to go back up here. The highest frequency I have went up to 8. How you decide your numbers, that's up to you. You could go by 1s, you could go by 2s. This part, there's no just one right answer. I'm going to go by 2. So I'm going to go 2, 4, 6, 8, and I'm going to go up to 10. Okay. And then under here is where I'm going to show A, B, C, D, and F. I'll switch colors just so I can make this a little more interesting. My lines are not, I'm going to tell you, drawing on this little tablet I have, my lines are not going to be great. But for example, I look back at the A, I'm going to scroll up here. The A's had a frequency of 3. So here I'm going to draw up to approximately 3, and that would be my A. For the B had an 8. So I'm going to go up to the 8. That's the best I'm going to do there, not very straight. And there's my B. For C, we had 7 of those, so that's right about there. Also, just so you know, the bars should be the same width. I am struggling with that with this, but technically they should be the same width. We don't draw one thinner or thicker than the other on purpose. I tend to use Excel. So when I do my graphs to show any type of data, I use Excel. For me, I just love, I've been using it for years, so it's very quick for me to enter my data on there and then just have it create a bar graph. If you are asked to do a histogram, here's the difference. Your bars will not have a gap. They will touch, okay? So the bars will have a gap in a bar graph, but in a histogram, they do not. And then we have something called a pie chart, and I didn't want to draw this one, so this one I actually did put up here. But basically, it represents the entire sample, and each slice represents the category. It's actually the relative frequency. Notice our relative frequency. This is from the grade chart that we did. Notice all of the relative frequencies are listed here because and the size of the pie chart is the actual size. So this is a third of the circle. This right here would be 12.5% of the circle. This should always give you 100%. Now, if we're rounding, it might add up to like 99.9% or so forth. But roughly you want the circle to be 100% because that would be your relative frequency altogether. The total would be 100% of the data. All right, so that ends our section on just a little bit of an introduction on just how we can organize and display our data.